Inequalities. Inequalities are a range of values rather than one value. During the course of this lesson, we'll solve questions on inequalities, talk about types of inequalities, and graph inequalities as well. So when we have an expression such as y equals 2, this just simply means that y is equal to 2. But how about to have something like y is greater than 2? It's different. This simply means that y can be any value above 2, such as 3, 4, 5, 6, 7, up to infinity continues. And this implies that y is not equal to 2. Let's talk about the four basic inequality signs, starting with the strong inequality. Here we'll have greater than. For instance, we can say x is greater than 4. It simply means that x are range of values above 4. We cannot start from 4. So here means that x can be values such as 5, 6, 7, 8, and up to positive infinity. Now let's talk about less than. So for this strong inequality, when we say x is less than 10, it simply means x are range of values less than 10. So we have 9, 8, 7, 6, and up to negative infinity. So it means it is less. Let's go to weak inequality. For the weak inequality, we'll have greater than or equal to, and it's a little bit different from the strong inequality. So we write the symbol in this form. So we'll have more like an equality sign attached to it. So when we say x is greater than or equal to 5, simply means x values are 5. We have to start from 5, unlike strong inequality where you skip the immediate number. So we'll start from 5, then we'll have 6, we'll have 7, we'll have 8, we'll have 9, and then it continues till positive infinity. Same applies to the less than or equal to, which is another kind of weak inequality. So we have this equality attached to the symbol. So when we say x is less than or equal to 10, it simply means we have range of values as 10. So we have to start from that immediate value first. We have 10, we have 9, we have 8, we have 7, we have 6, and up till negative infinity. So what is the logic behind this? To differentiate between the strong and weak inequality, we know that while we deal with the strong inequality, we skip the present number. So we just go above the immediate number we have. But while dealing with the weak inequality, we have to work from the immediate number we have. I think we need to solve questions on this and then clarity comes in. Let's go. Okay, we have an example. Solve the equation x plus 2 equal to 4. Now, this is not an inequality. I want you to pay attention simply because we have an equality here. Now, look at this. We have an equality sign here, but then here we have an inequality. So here is an equation. Let's solve this equation. We have x plus 2 is equal to 4. Now, for you to understand the whole process and the method I'm going to apply to solve this equation is ideally go to the lesson on linear equation, one-step linear equation especially. Okay, so at this very point, we have to do the opposite operation. We have plus connecting x and 2. What do? We subtract. So 2 from both sides, such that we have x plus 2 minus 2 is equal to 4 minus 2. Then here the 2's cancel out because plus 2 minus 2 is 0. So we have x, we're left with x is equal to 4 minus 2 is what? 2. Therefore, x is equal to 2 and we are done. So we solve the equation and the answer of this equation is just 2. But then how about we have this in an inequality? What do? Is there any variation? We have x plus 2 is greater than 4. So we also have to subtract 2 from both sides because we have a positive 2 connecting x and the constant, which is on the left hand side. So at this point, we say x plus 2 minus 2 is greater than 4 minus 2. Plus 2 minus 2 cancels out, so that we'll have x is greater than 4 minus 2 is just 2. I want you to know something. X is not equal to 2. This is a strong inequality and it says that x is greater than 2. It simply means the value above 2 are the range of values of x. So therefore, x is equal to what? Or x are the following values: 3, 4, 5, 6, 7, and up till positive infinity. So that is the difference between an inequality and a traditional equation. So for your traditional equation, the variable is just equal to a specific value, while for your inequality, we'll have range of values. Is that clear? I hope this is making sense. Let's go ahead and solve more questions. Okay, so we'll have a task. The question says, which of these is a possible value of x in inequality? So we'll have x minus 3 is greater than 5. Now, since we have negative connecting this constant and variable, what do? We employ a positive. So we have to add 3 to both sides, right? Doing that, we have x stands alone on the left hand side is greater than minus 3 plus 3 cancels out, and then 5 plus 3 is 8. So now I want you to pay attention to this kind of question. This is a trick. A is very much wrong. It's a trick. So you might quickly pick A. You know that x is not equal to 8, right? That x a range of values such as what? 9, 10, 11, 12, and then up to positive infinity. But then you might quickly rush and pick 8 because you think you're solving for a traditional linear equation. No, this is inequalities. So inequalities, we work with range of values. So right here, let's check for 2. 2 does not even come in. It's not close because x is actually, if x is greater than 8, it simply means x is way, way greater than 2. It doesn't make sense. But now it makes sense because in our range of values, you can see we have 9 as one of the values. Then 3 doesn't make sense at all. So the right option here is C. Okay, we'll have more questions. Number 1 here says, solve the inequality 2x is greater than 9. So 2x greater than 9. Now, mind you, we have 2 and x on the left hand side. So that's 2x. And what is the relationship between this constant and the variable? Is a multiplication. And when we have multiplication connecting a constant and variable, what do? We divide. So we have to do what? Divide both sides by 2. Doing that, we have 2x over 2 is greater than 9 over 2. The 2's cancel out, and then we have x is greater than 9 divided by 2 gives you 4.5. So it simply means that x is not equal to 4.5, never. But x a range of values such as what? 4.6, just above it because it's greater than, and this is a strong inequality. 4.6, 5, 5.3, 8, and just so the logic here is that x is greater than, so whatever value that is greater than our x stands. It makes sense and it can work. Let's solve the second question. So number 2, we have that 4x plus 2 is greater than 22. Here we have a two-step equation. So go through the lessons on linear equation. They will actually get you grounded and get you started with how to resolve a linear equation problem. So at this very point, we'll have a plus connecting our variable. So what do? We have to subtract 2 from both sides. Doing that, we have 4x plus 2 minus 2 is greater than 22 minus 2. So the 2's here cancel out, and then we'll have 4x is greater than 20. But then we still have a coefficient here. So the coefficient of our variable, which is x, is 4. Because we have that coefficient, we'll have to divide both sides by 4. So that we'll have 4x divided by 4 is greater than 20. How to sketch the number line. The number line increases from left to right. Okay, you're wondering, what are we going to do with number line? How is it going to help us? So the number line is going to help us see how the numbers connect. So let's go ahead and do this. Now for the number line, you want to start from the 0. So you have 0. Let's say this is our origin, our takeoff point. So, and then to the right, which means going towards these points, we'll have positive values. And then to the left, going towards this end, we have negative values. So here you have 1, 2, 3, 4, 5, 6, but it doesn't just end up to positive infinity, which means is endless. Why on this other end, you have your -1, -2, -3, -4, -5. It doesn't just end here, negative infinity. So if I'm to label this, I want to say this is the neutral points, and these are the positive values extending to the right, that is increasing, and here are the negative values decreasing to the left. So I want to give you this diagram to help you picture what I've been talking about. So we have this. Watch this. So it simply means that 0 from this point what is greater than -5, and -1 is as well greater than -3. So it increases from what? From the left to the right. So for instance, assuming we say that x is less than -1, assuming we have this, it simply means that x is not equal to -1, right? So what are the values of x? You can simply see this from the number line. What we simply do is that we go towards the negative because it's saying less than. So because we have a less than, we extend towards the negative. And right here we have what? -2, -3, -4, -5. I hope this makes sense to you. Okay, let's do one more. Assuming we say x is less than -3. So it simply means that x is not equal to -3, right? So what are the possible values of x? We have what? That x is equivalent to what? The following range of values, such as -4, -5, -6, -7, and up to what? Negative infinity. So it's endless. I hope this makes sense to you, right? So I have questions to solve on weak inequalities. Let's start from the number one. For the first one, we have -4 is greater than or equal to 2x plus 2. From this point, you see that we have a positive connecting this constant and our variable. Because we have a positive, what do? We subtract. So let's subtract 2 from both sides. So we have -4, -2. That is -4 minus 2 is greater than or equal to 2x plus 2 minus 2, so that the 2's cancels out. -4, -2 gives us -6, that is -4 minus 2. Then it's greater than or equal to 2x. What's the next step? Because we have a coefficient here, we divide both sides by what? 2. So we have -6 divided by 2, then or equal to 2x divided by 2. The 2's cancel out, right? And then we'll have greater than or equal to that x. 2 here is 1, and 2 here is 3, so we'll have -3. So have -3 is greater than or equal to x, which is same as saying that x is less than or equal to -3. So how can we figure out the range of values for x? It's simple. We can actually sketch a number line. So let's do that here. Because it's a negative, we might not need to pay attention to the positive axis. So let's say this is our origin, which is 0. Here we have 1. We'll have 2, but that's not our interest. So going to the negative, we'll have -1, -2, -3, -4, and maybe -5. Let's just stop here. Okay. Now I want you to see this. That's why I'm doing this. So because it's a weak inequality, it means we are going to start from the immediate value, unlike strong inequality where we skip the immediate value. So it simply means that x is actually equal to -3, and it makes sense. So therefore, the possible values of x or range of values of x are what? -3, -4, -5, and then up to -infinity. So remember, they said less than or equal to. So we'll start from that immediate value, and then we'll keep going down, going down, going down, going down. And then I just want you to understand what's happened here. So When we say that negative 3 is greater than x, simply means x is actually less than it. Okay, let's say for instance, when you say a 20-year-old person is greater than a 15-year-old person, it simply means that a 15-year-old person is actually less than a 20-year-old person. So there is nothing difficult here. It's just for you to understand it. For the second question, we have that 2x plus 4 is less than or equal to 2. So because we have a positive connecting a constant and a variable, what do? We subtract. So subtracting 4 from both sides gives us 2x plus 4 minus 4 is less than or equal to 2 minus 4. The first cancels out and I will have 2x is less than or equal to negative 2. So what's the next step? Divide both sides by 2. So I have 2x divided by 2 is less than or equal to negative 2 over 2. And then x is less than or equal to negative 1. So because it's not equal to negative 1, we know that x is actually equal to negative 1. But then what are the possible range of values for our x? So x range of values can include what? Negative 1, negative 2, negative 3, because they are saying it's less, and then negative 4. So if you look at our number line, when they say it's less than, what do we simply do? We have to start decreasing towards the left. So all these values that are decreasing towards the left are the possible values for x. And then finally we have 1 is greater than or equal to 6x minus 11. Since we have a negative connecting constants and variable, what do? We add. So 1 plus 11, adding 11 to both sides, greater than or equal to 6x minus 11 plus 11 cancels out. Here we have 12 is greater than or equal to 6x. For the next step, we divide both sides by the coefficient of our variable, which is 6. So 12 divided by 6 is greater than or equal to 6x divided by 6. The 6 here cancels out, so that we'll have what? That x is, okay, this is 6 here is 1, 6 here is 2, so we can say 2 is greater than or equal to what? X, which is same as saying x is less than or equal to 2. So it simply means we are going to start from the positive here and then decrease down. So possible values for x, and you know x is obviously equal to 2. Makes sense, but that's not just only it. We'll have other range of values. So x are values such as what? 2, 1, 0, -1, -2, and all that. I hope this is clear. How to solve complex inequality questions. Note, revise the inequality sign whenever you multiply or divide both sides by negative numbers. So let's go ahead and solve the questions we have here. Number 1, we have 5 minus x is greater than 3. You may say the sign connecting our constant and our variable is negative, but it is not. The aim of what you want to do is that you want to eliminate the constant. And if you should add 5 to both sides, this constant becomes 10. You've not eliminated it. So what do? We focus on the sign of the constant to know whether we add to subtract or to add. Let's look at this. When you have negative 4, when you have negative 6, and when you have 6, for instance, the sign of 4 here is what? Negative. Sign of 6 here is what? Negative. But the sign of plus here is what? Positive, right? So what you want to note is that the sign of a number is the sign in front of that number to the left. And to the left of this value here is what? Of this 5 here. There is no value written. That simply means what? It is a positive. Doing that, it becomes 5 minus 5 because we are doing the opposite of the sign we have here. So we have plus at this very point. So there's no need to write it, but let me just put it down. We have plus 5. So we're going to subtract. So minus x is greater than 3 minus 5. So we subtracted what? 5 from, so that our constants can stand alone. So negative s is greater than what? Negative 2. What's the next step? The next step is to divide both sides by the coefficient of our variable. Coefficient of our variable here is negative, and this is 1x, right? Because of that is negative 1, just 1. So doing that, we have negative x over negative 1. But because we are dividing by a negative number, what do? We reverse the inequality symbol. So it's not going to be greater than anymore. It becomes less than. So negative 2 over negative 1. the negative cancels out, and x over 1 is something as x is less than the negative cancel out, and then here we'll have 2. It simply means that 1, x is not equal to 2, and you know that. So what are the possible values for x? We'll have what? 1, 0, -1, -2, and then etc up till your positive infinity. I hope this makes sense to you. Let's solve the next question. Next question says 19 is greater than or equal to 4 minus 5x. Pay attention, we have a weak inequality. So because we have a positive 4 connecting our variable here, what do? We subtract 4 from both sides. Doing that, we have 19 minus 4 greater than or equal to 4 minus 4 minus 5x. The 4 here cancels out, and then we'll have 15 greater than or equal to negative 5x. So what's the next step? We divide both sides by the coefficient of our x, which is negative 5, right? Because it's a negative, we'll have to do what? Reverse the inequality. Don't forget that you have to flip that inequality sign. So we'll have 15 over negative 5 is less than or equal to what? Negative 5x over negative 5. So 5 divided by 15 is 3, but remember the negative, and then is what? Less than or equal to the negative 5's cancels out, and then we'll have x. And this is same as saying that x is what? Greater than or equal to what? Negative 3. So you know that obviously x is as well equal to negative 3. But then what are the possible range of values for x? So greater than it simply means we have negative 3, negative 2, negative 1, 0, 1, 2, up to your positive infinity. So if you don't understand this clearly, I think you want to sketch the number line so that you can see this for yourself. Graphs of inequalities. So let's say we have this. So I'm going to put up some arrow here. We are increasing. So we also have another one. So these are the ones talking about greater than. But then for the strong inequality, you don't have to shade here. But for the weak inequality, you shade this box. So it's being shaded. So I'm shading it now. While for the less than or equal to, we'll have it facing towards this end. And then you still have this. So we'll have this other one still facing towards this end. So this is for the strong inequality, and this is for what? The weak inequality. So you have to shade the end of the weak inequalities. Doing that, so this means, what does this means? Greater than. Why this means what? Greater than or equal to. This means what? Less than. And what does this means? Less than or equal to. So this is very, very essential as regards to graphing of inequalities. So let's go ahead and graph some inequalities. Okay, so we'll have a couple of questions to solve here. We'll solve them and graph their inequalities. So for number 1, we say that x is less than 2. So when we let's put up our number line first. So our number line, we start from the neutral, which is 0. Then where do we have positive? So we have 1, positive 1, positive 2, positive 3. I think we can just stop here. It's fine. So they said x is less than positive 2. So these are positive 2. We draw a circle there at positive 2. Less than simply means what? We are pointing towards this end. And then you don't need to shade this. So this is our graph for x is less than 2. Let's solve the next one. The second one says that s is greater than negative 3. So doing that, we have our number line graph. So starting from 0, okay, here we have negative 3, negative 2, negative 1, right? So here is 1, here is 2. But our attention is on the negative 3. So x is greater than negative 3. So starting here is our negative 3. Because it's greater than, we have to extend towards the right. The length of this arrow is not really necessary. It can be short, it can be small, but let it indicate that it's moving towards the right or moving towards the left. So here it's moving towards the right, while here we had this moving towards the left. So having said that, this becomes our equation for x is greater than negative 3. So I like to write my equation on the graph, but it's still fine if you don't do that. So these are strong inequalities, don't need to shade their end. But let's check number three. So we said number three says x is greater than what or equal to -1. So doing that, we start from -1, right? So we need to capture -1. So let's say 0, -1, -2, then 1, 2. So these are the points we outlined. From -1, we'll have to do what? To put a circle on -1. Putting a circle on -1 is a weak inequality. We'll have to shade it, and then it's progressing. So take it front, going towards the right. So it extends to the right, and then you have x is greater than or equal to what? -1. So let's say 4, that x is less than or equal to +4. Putting up a graph, we have 4 because it's less than, so it simply means it's going to decrease. I want to start from 5. We have 4, 3, 2, 1, then 0 minus 1. So these are the values we have. So from 4, we'll put a circle on 4 because our interest is on 4. So what's the next step? Because it's less than or equal to, we'll have to decrease to the left, and then we shade because it's a weak inequality. So take note of this tiny detail. So x is less than or equal to what? 4. And we are done graphing these inequalities. So it is that simple, like very, very much simple. No complex work here to do, no racking of brain, just simple. Inequalities are actually very, very simple. Okay, and finally, we'll have one more question to solve, and voila, we are done. Solve the inequality 6 is less than or equal to 2x minus 1. We have a negative for our constant here. Because of that, we have to add. So add 1 to both sides. 6 plus 1 is less than or equal to 2x minus 1 plus 1. This cancels out, and then we'll have 7 is less than or equal to 2x. So what's the next step? The next step is to divide both sides by what? 2. So have 7 over 2 is less than or equal to 2x over 2. So here, 7 divided by 2 gives you what? 3.5, right? 3.5, and then it's less than or equal to, the 2's cancels out and we'll have x, which simply means that x is greater than or equal to what? 3.5. Because if 3.5 is less than x, it simply means that x is actually greater than it. So let's graph this. So graphing this, because of the points, I'm going to also make use of points. So let's say this is our 0. Our 0 is here. So here becomes, I can have, let's say 1, 2 here, 3 here. So I just want to accommodate more values. 4, 5. It's good like this. So this is -1. Then we have to start from what? 3.5. It simply means 3.5 is somewhere here. So that we can have 3.6, 3.7, or up to 4. Then this is what? 4.5. This is 2.5. The midpoint, this is 1.5. And this is 0.5, right? So because we are interested in 3.5, we'll have to put up our circle here. Greater than simply means what? We are extending to the right. But then this is a strong inequality. So what do? We shade this. And then if you want, which is not compulsory, you can write your equation here like I always enjoy doing. And that is it. So having said that, we've come to the lesson on inequalities, solving questions on inequalities and graphing them. And you did that. That is so beautiful. Thank you so much for joining us. And do well to join us some other time. Have a wonderful time.